Imagine stepping outside right now and finding yourself in a world you wouldn't recognize. The air is different, colder, sharper, filled with sounds that don't exist anymore. In the distance, you see something moving. It's massive, covered in thick reddish fur, with tusks that curve toward the sky. A woolly mammoth. Beyond it, across endless grasslands that stretch where your city should be, there are giant ground sloths the size of elephants, saber-toothed cats prowling through forests of spruce and pine, and short-faced bears that stand 12 feet tall when they rear up on their hind legs. This isn't science fiction. This was Earth. 12,000 years ago, this was home. The planet was locked in the grip of the last ice age. Glaciers 2 miles thick covered Canada, Northern Europe and Asia. So much water was trapped in ice that sea levels were 400 feet lower than today. You could walk from Siberia to Alaska. Britain was connected to mainland Europe. The coastlines of every continent looked completely different, and everywhere, in almost every ecosystem, there were giants, megafauna, animals so large and so numerous that it's hard to believe they're gone. Then something happened. Between roughly 12,800 and 11,600 years ago, the world changed. Not gradually, not slowly, rapidly, catastrophically. The ice began to melt. Sea levels rose hundreds of feet. Temperatures swung wildly, first plummeting into a deep freeze, then surging upward. And in what seems like the blink of an eye in geological terms, approximately 35 genera of large mammals went extinct across North America alone. Worldwide, the losses were staggering. The mainstream explanation is straightforward. The Ice Age ended because of predictable changes in Earth's orbit and tilt. The big animals died out because of climate change and human hunting pressure. It was a natural transition. Unfortunate for the megafauna certainly, but nothing mysterious. Just the way these cycles work. But here's the thing. The more we dig, literally and figuratively, the more questions pile up. Questions that don't have neat answers. Questions that mainstream science sometimes seems reluctant to fully address. Why do hundreds of cultures around the world, separated by vast oceans, share remarkably similar stories of a great flood? Why do we find evidence of massive wildfires that scorched continents at exactly the same moment in time? Why are there layers of sediment containing materials that shouldn't be there? Microscopic diamonds, platinum anomalies, spherules that suggest extreme heat. Why do some geological formations look less like gradual change and more like something violent and sudden happened? And perhaps most intriguing of all, why do we keep finding structures underwater, on continental shelves that used to be dry land, that look suspiciously like they were built by humans, during a time when we are told humans were still living in small hunter-gatherer bands? Tonight we're going to explore what really happened when the Ice Age ended. Not just the accepted narrative, but the mysteries that linger at its edges, the evidence that doesn't quite fit, the theories that challenge everything we think we know about our past. We'll look at the Younger Dryas impact hypothesis, the idea that something from space might have triggered the chaos. We'll examine the flood myths that seem to preserve memories of real catastrophes. We'll consider the possibility that civilizations more advanced than we've been told might have existed before the ice melted and the seas rose. We're not here to tell you what definitely happened. Nobody can do that with absolute certainty. We're here to explore the possibilities together, to wander through the shadowy territory between established fact and tantalizing mystery, to ask the questions that make us wonder about the world that vanished overnight and the one that emerged from the flood. The story of the Ice Age's end is the story of the world we inherited, and it might be far stranger, far more dramatic and far more mysterious than anything you learned in school. Let's begin at the beginning, or rather, at the ending that became our beginning. Picture Earth 26,000 years ago. Not the Earth you know, not even close. This is a world locked in the grip of what scientists call the last glacial maximum, the deepest freeze of the most recent ice age. And when we say ice age, we're not talking about a few cold winters or some extra snow in the mountains. We're talking about ice sheets so massive, so incomprehensibly thick, that they literally press down on the continental crust beneath them, deforming the shape of the planet itself. Over North America, ice stretched from the Arctic Ocean south to where New York City stands today. Not a thin layer, not a heavy winter's accumulation. Ice 2 miles thick in places. 2 miles. Stack 7 Empire State Buildings on top of each other, and you're still not at the surface of the ice sheet. The weight was so enormous that the land beneath it sank hundreds of feet into the Earth's mantle. We can still measure this geological depression today. The land is still rising, still rebounding from the weight of ice that melted 12,000 years ago. Europe was equally buried. The Scandinavian ice sheet covered everything from Scotland to Moscow, grinding mountains into valleys, carving fjords that would later become legendary landscapes. The Alps had their own ice cap separate from the main sheet, sending glaciers in every direction like frozen tentacles. Asia had massive ice fields across Siberia, though interestingly not everywhere you might expect. Some of the coldest regions were actually ice-free, too dry to accumulate the snow needed for glacier formation. These became frozen grasslands, strange ecosystems that existed nowhere on Earth today. But here's where it gets really wild. All that ice had to come from somewhere. Water doesn't just appear out of nowhere. The glaciers were built from ocean water evaporated, carried inland by storms, and deposited as snow that never melted, year after year, century after century for thousands of years. The oceans were being mined to build mountains of ice, and the result was that sea levels dropped, not by inches or feet, but by roughly 400 feet below where they stand today. Think about what that means. The coastlines, the beaches, the port cities, the seaside cliffs, none of them existed as coastlines during the last glacial maximum. They were inland territories, sometimes hundreds of miles from the actual shore. The continental shelves that today lie beneath a few hundred feet of water, those were dry land. Vast plains, river valleys, forests, entire landscapes that have been underwater for 12,000 years. Between Britain and mainland Europe there was no English Channel. Instead there was Doggerland, a massive plain with rivers and lakes and hills, probably one of the richest hunting grounds in Ice Age Europe. Fishermen still pull up Stone Age tools from the bottom of the North Sea, artifacts from a drowned world. Between Siberia and Alaska, the Bering Land Bridge was 1,000 miles wide, a subcontinent in its own right. Indonesia, the Philippines, Malaysia, they were all connected. Part of a vast landmass called Sunderland. You could walk from Bangkok to Borneo without ever getting your feet wet. And in these transformed landscapes lived creatures that seem like they belong in mythology, but were absolutely real. Woolly mammoths, massive as modern elephants but adapted to brutal cold, with thick fur coats and enormous curved tusks that could sweep snow aside to reach the grass beneath. They weren't exotic rarities. They were everywhere across the northern hemisphere, herds of thousands moving across the frozen grasslands like bison once crossed the American plains. Alongside them roamed creatures that would terrify any modern wildlife photographer. Woolly rhinoceroses, built like tanks with horns that could gore a predator or defend territory. Giant ground sloths the size of elephants, moving through Ice Age forests on their knuckles because their claws were too large to walk normally on. Saber-toothed cats with canines so long they had to develop special jaw joints just to open their mouths wide enough to use them. Cave bears that dwarfed modern grizzlies. Dire wolves hunting in packs. Glyptodons, basically armadillos the size of small cars. This was the Pleistocene megafauna, and they dominated every continent except Antarctica. 'They had evolved over millions of years to thrive in Ice Age conditions, each species perfectly adapted to a world of ice and cold grasslands and extreme seasonal variation. And living among them, hunting them, avoiding them, studying them, were humans. Not primitive cave dwellers barely clinging to survival, the old stereotype has it, but sophisticated hunter-gatherers with deep knowledge of their environments, complex social structures, and technologies that allowed them to thrive in conditions that would kill most modern people in hours. They wore tailored clothing made from animal skins sewn with bone needles and sinew thread. They built substantial shelters, sometimes from mammoth bones and hides where wood was scarce. They created art, carved figurines, painted cave walls with images so beautiful they still move us today. Before we go further into this frozen world, I'm curious about your world right now. If you're comfortable sharing, drop a comment and let me know where you're watching from and what time it is where you are. Are you in Australia watching the sun come up? Europe settling in for the evening? North America deep in the middle of the night? There's something special about knowing we're all scattered across the planet, different time zones, different circumstances, but all here together exploring these ancient mysteries. It's almost like those Ice Age humans, small groups separated by vast distances, but connected by shared curiosity about the world. So, this was the world. Ice and grassland and megafauna and humans. A world that had existed in roughly this state for tens of thousands of years. Stable in its extreme cold, predictable in its harshness. The glaciers advanced and retreated a bit with natural climate cycles, but the overall pattern held. Ice in the north, cold grasslands in the mid-latitudes, tropical regions compressed toward the equator. For generation after generation after generation, this was simply how Earth was, except it wasn't going to last. Something was about to change, and when it did, it would happen so fast, so dramatically, that the world those Ice Age humans knew would quite literally melt away beneath their feet. The question that still puzzles scientists today is why? Why did this stable Ice Age world suddenly end? And more mysteriously, why did it end so abruptly, so catastrophically, bringing not just warming, but chaos? That's where our story really begins. Let's talk about what you were taught in school. The official story, the version that's in every textbook, every documentary, every museum display about the end of the Ice Age. Because before we explore the mysteries and the anomalies, we need to understand the mainstream explanation. And to be fair, it's actually pretty elegant. According to conventional science, the end of the Ice Age was gradual, predictable, and driven by forces so massive and methodical that you could set your calendar by them. Literally. The story goes like this. Around 19,000 years ago, Earth's climate began warming. Not because of anything happening on Earth itself, but because of subtle changes in our planet's relationship with the Sun. These changes are called Milankovitch cycles, named after the Serbian mathematician who figured them out in the 1920s. Here's how they work. Earth's orbit isn't a perfect circle, it's an ellipse, and that ellipse changes shape over roughly 100,000 years, sometimes more circular, sometimes more elongated. Earth's axial tilt, that 23.5 degree lean that gives us seasons, isn't constant either. It wobbles between 22.1 and 24.5 degrees over a cycle of about 41,000 years, and the direction Earth's axis points changes too, rotating in a slow circle over about 26,000 years. This is called precession. These three cycles, orbit shape, axial tilt and precession, they interact in complex ways, changing how much solar radiation different parts of Earth receive during different times of the year. And according to mainstream science, these orbital mechanics are what drive ice ages. When the cycles align just right, northern latitudes receive less summer sunlight. Snow that falls in winter doesn't fully melt in summer. Year after year the snow accumulates, compressing into ice, building into glaciers, spreading into ice sheets that eventually cover entire continents. When the cycles shift again, summer sunlight increases. The ice begins to melt, slowly, predictably, over thousands of years. The conventional timeline says this is exactly what happened starting 19,000 years ago. The Milankovitch cycles shifted into a warming configuration. Summer sunlight in the northern hemisphere increased. The massive ice sheets that had covered Canada, Scandinavia, and northern Asia began their long, slow retreat. For the next several thousand years, the ice melted steadily. Sea levels rose gradually. Ecosystems shifted northward as temperatures climbed. By about 11,700 years ago, the process was essentially complete. The Ice Age was over. Welcome to the Holocene, the relatively warm, stable climate period we're still living in today. And you know what? This theory explains a lot. It accounts for the long-term pattern of ice ages and warm periods throughout Earth's history. It matches ice core data from Antarctica and Greenland showing slow temperature increases over thousands of years. It fits with geological evidence of glacial retreat, with fossil records showing gradual ecosystem changes, with sea level reconstructions showing steady rises as ice turned to water. The mathematics work, the physics work, the timeline makes sense. Geologists can point to terminal moraines, those piles of rock and debris left behind by retreating glaciers, and show you exactly how the ice sheet shrank back over millennia. Paleoclimatologists can show you sediment cores from lake beds documenting slow changes in vegetation as the climate warmed. Pollen preserved in those sediments tells the story of tundra giving way to grasslands, grasslands yielding to forests, all happening in an orderly progression as temperatures rose degree by degree, century by century. It's a beautiful theory, clean, testable, supported by multiple lines of evidence. For decades, it's been the foundation of our understanding of climate change, both past and present. Every undergraduate geology student learns it. Every climate model incorporates it. It's as close to scientific consensus as you can get. But here's the thing about consensus. Sometimes it's a sign that we've found the truth, and sometimes it's a sign that we've stopped asking uncomfortable questions. Because when you look closer, when you really examine the evidence from the end of the Ice Age, you start noticing things that don't quite fit. Anomalies, outliers, data points that make you tilt your head and go, wait, that doesn't make sense if everything was gradual. Like the fact that dozens of megafauna species went extinct in what looks, geologically speaking, like an instant. Mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, American camels, horses, all across North America, all basically at the same time. The conventional explanation is that gradual warming changed their habitats and human hunting pressure finished them off. But these were species that had survived multiple previous warming periods. They'd made it through climate changes before. Why did they all suddenly fail this time? Or consider the evidence for catastrophic flooding? Not gradual sea level rise, but massive violent floods that carved channels hundreds of feet deep through solid bedrock. The channeled scablands in Washington state, where geologist J. Harlan Brett spent decades fighting the scientific establishment to prove that millions of gallons of water had ripped across the landscape in a matter of days, not centuries. He was right, but it took 40 years for the consensus to accept it. Then there's the carbon layer. Multiple sites across North America show a distinct black matte layer in sediments, dating to right around the end of the Ice Age. It's rich in carbon, full of microscopic spherules that look like they formed under extreme heat. Some researchers see evidence of wildfires, continental-scale wildfires, the kind that would require something more dramatic than gradual warming to ignite. And the temperature data itself. When you zoom in on the details, the warming wasn't nearly as smooth as the simplified version suggests. There are spikes, sudden jumps, periods where temperatures seem to have risen several degrees in just decades, maybe even years. That's not what you'd expect from slowly changing orbital mechanics. The most dramatic example is the Younger Dryas event, but we'll get to that shortly. For now, just know this. The conventional timeline of gradual, orderly warming has cracks in it. Significant cracks. The kind that make you wonder if maybe, just maybe, there's more to the story than celestial mechanics and melting ice. The mainstream explanation isn't wrong exactly. The Milankovitch cycles are real. Orbital changes do drive long-term climate patterns, but increasingly evidence suggests that something else happened too, something sudden, something catastrophic, something that turned what should have been a slow, steady transition into a crisis that reshaped the world in the geological blink of an eye. So what really happened when the Ice Age ended? To answer that, we need to look at one of the strangest, most controversial periods in Earth's climate history. A time when the warming stopped dead in its tracks, and the world plunged back into Ice Age conditions almost overnight. Picture this. You're living 13,000 years ago. Your ancestors have been watching the ice sheets retreat for thousands of years. Forests are spreading across landscapes that had been frozen wastelands for millennia. Animals are returning, herds of them. The hunting is good. The climate is warming steadily, predictably. Everything suggests the Ice Age is ending, that your children and grandchildren will inherit a world warmer and more abundant than anything your people have known for generations. And then, within a human lifetime, maybe within a single decade, everything reverses. The warmth disappears, the rains stop. The ice sheets that had been steadily melting suddenly surge forward again, grinding across valleys that had just begun to bloom with life. The forests die back. The herds vanish. The world freezes again. Not gradually, not over thousands of years like orbital mechanics would predict, but catastrophically fast. This actually happened. And we still don't fully understand why. Welcome to the Younger Dryas, one of the most disturbing and mysterious climate events in recent Earth history. It lasted from approximately 12,900 to 11,700 years ago. A little over 1,000 years of renewed Ice Age conditions that appeared out of nowhere, right in the middle of what should have been steady, predictable warming. The timing alone is bizarre. For roughly 7,000 years before the Younger Dryas, the planet had been warming consistently. The Laurentide ice sheet covering North America was melting. Sea levels were rising steadily. Temperatures across the northern hemisphere were climbing at exactly the rate you'd expect from Milankovitch cycles, those orbital variations that drive Ice Age timing. Everything was following the script. The Ice Age was ending right on schedule. Then around 12,900 years ago, the script got torn up. Temperatures in the North Atlantic region dropped by 15 degrees Celsius. Not over centuries, not even over decades, but possibly within years. Ice cores from Greenland show the transition happening so fast that scientists initially thought the data must be corrupted. But it wasn't. The drop was real, and it was catastrophic. Within a single generation, maybe less, the climate of the northern hemisphere lurched back into full glacial conditions. Snow began piling up again in regions that had been ice-free for thousands of years. Alpine glaciers that had been retreating suddenly began advancing. The tree line in Europe and North America shifted hundreds of miles south. Animals that had adapted to warming conditions either migrated desperately or died. For humans living through it, the change must have been incomprehensible. Imagine being a child during the last warm years, then becoming an elder in a world of ice and cold that your grandparents swore had been vanishing. Imagine trying to explain to the next generation that yes, the world had been warm once, that forests had grown where now only tundra survives, that the stories of abundance weren't just myths, but memories. The mainstream explanation for the Younger Dryas involves ocean currents and meltwater. The theory goes like this. As the great ice sheets melted, massive amounts of fresh water flowed into the North Atlantic. This fresh water was less dense than seawater, so it sat on the surface like a lid, disrupting the normal circulation patterns that carry warm water from the tropics to the polar regions. Without that warm water flowing north, the entire northern hemisphere cooled dramatically. It's a neat theory. It accounts for some of the evidence, but it has problems, big ones. First, the speed. Ocean circulation changes happen over decades or centuries, not years. Yet some ice core data suggests the temperature drop happened within a human lifetime, possibly much faster. Second, the geographical pattern. The Younger Dryas cooling was most intense in the North Atlantic region, which fits the meltwater theory. But significant cooling also occurred in areas that shouldn't have been as affected by Atlantic Ocean circulation. Places like the Middle East, parts of Asia, even regions in the Southern Hemisphere. Third, and most troubling, the end of the Younger Dryas is even more abrupt than the beginning. Around 11,700 years ago, temperatures didn't just recover, they spiked. The warming that occurred at the end of the Younger Dryas happened absurdly fast. Ice core records from Greenland show temperature increases of 10 degrees Celsius within a decade, possibly within 3 years. Some researchers argue the transition could have happened even faster, within months or even weeks. This is not normal climate behavior. This is not how orbital mechanics work. This is not what ocean currents do. This is something else, something that operates on timescales that should be impossible for global climate systems. The paleoclimate data is unambiguous. The Younger Dryas happened. The temperature drops and spikes were real. But the mechanism remains hotly debated, and the standard explanations feel inadequate when you really look at the evidence. What could cause the entire northern hemisphere to freeze within years, then thaw just as quickly a millennium later? What kind of event operates that fast, yet affects such a massive region? Here's where things get controversial, because if normal climate processes can't explain the Younger Dryas, then we have to consider abnormal ones, catastrophic ones. Some researchers have proposed that the Younger Dryas wasn't caused by gradual processes at all. Instead, they argue for a triggering event, something sudden and violent that shocked the climate system into a different state. What kind of event? That's where the theories diverge, where mainstream science meets more speculative ideas. But the basic premise is hard to ignore. The Younger Dryas doesn't look like normal climate variation. It looks like something hit the pause button on the end of the Ice Age, freezing the warming trend for 1,000 years before suddenly letting it resume. The question that keeps researchers up at night is simple but profound. What has the power to pause and then restart global warming on timescales of years, not millennia? What could cause temperatures to plummet and spike in patterns that seem to violate everything we know about how climate works? The answers being proposed are fascinating, controversial, and sometimes frightening. Because if the Younger Dryas was triggered by something catastrophic, something that could happen again, then understanding it isn't just an academic exercise. It's a matter of survival. But before we can explore those theories, we need to understand just how strange the evidence really is. Because the mystery of the Younger Dryas gets deeper the more closely you look. So here's where the story gets really wild. You've got the Ice Age ending, glaciers melting, and then suddenly everything reverses. The Younger Dryas hits like someone flipped a switch. Temperatures plummet. Ice sheets that were retreating start advancing again. And this all happens in maybe a decade, possibly less. For years, scientists scratched their heads trying to explain it. Changing ocean currents, they said. Meltwater disrupting the Atlantic circulation. Perfectly reasonable, perfectly logical, perfectly unsatisfying. Because the more they looked, the more they found evidence that something else happened. Something dramatic. Something from the sky. Around 12,900 years ago, right at the boundary between the Ice Age and the Younger Dryas, There's a layer in the geological record that doesn't make sense. It shows up across North America, Europe, parts of Asia, even down in South America. This isn't supposed to happen. Local geological layers are local. They reflect whatever was happening in that specific region. Rivers flooding, volcanoes erupting, forests burning. But this layer is global, and it's full of things that shouldn't be there. Nanodiamonds. These are microscopic diamonds that only form under extreme pressure and temperature. The kind you get from massive impacts or nuclear explosions. They're scattered across this layer by the billions. Then there's the iridium. This metal is rare on Earth's surface, but common in asteroids and comets. Finding elevated iridium levels is like finding a cosmic fingerprint. It's the same signature that marks the dinosaur extinction 66 million years ago. Magnetic spherules, tiny balls of melted rock that cooled rapidly after being launched into the atmosphere, shocked quartz, crystalline structures that only form when rock is subjected to pressures that don't exist naturally on Earth's surface, and soot. Massive amounts of it, suggesting continent-scale wildfires all happening at the same time. This is what scientists call the Younger Dryas boundary layer, and it's exactly what you'd expect to find if something very large and very fast slammed into our planet. The hypothesis goes like this. A comet, maybe a fragment of a larger body that broke apart in the inner solar system, entered Earth's atmosphere around 12,900 years ago. It didn't necessarily hit as one object. It might have been a debris field, multiple fragments striking across North America and possibly Europe in a span of minutes or hours. Some impacts would have struck the massive ice sheets, covering Canada and northern Europe. Others hit land directly. The results would have been catastrophic beyond anything in human memory. Imagine an ice sheet 2 miles thick getting hit by a fragment travelling at tens of thousands of miles per hour. The energy release would have been equivalent to thousands of nuclear weapons. The ice doesn't just melt, it vaporizes. Millions of tons of water flash into steam and get launched into the atmosphere along with pulverized rock and ice. The shock wave alone would have flattened forests for hundreds of miles, and the heat, the initial fireball would have ignited everything flammable within line of sight. Multiple impacts across the ice sheet would have created massive meltwater floods, not the gradual melting that was already happening, but sudden, violent deluges that would have carved out entire landscapes in days. This is the flood of meltwater that probably disrupted the Atlantic Ocean circulation, the mechanism that actually triggered the Younger Dryas cooling. But it wasn't gradual climate change. It was impact-driven catastrophe. Then there's the Hiawatha crater. In 2018, researchers analysing radar data from beneath Greenland's ice sheet found something remarkable. A circular depression 31 kilometres across, hidden under a kilometre of ice. The shape, the size, the structure, it all matches impact craters on other planets. Dating it precisely is difficult because it's still buried under ice, but initial analysis suggests it could be exactly the right age. 12,900 years old, right at the Younger Dryas boundary. This crater alone would have released energy equivalent to thousands of megatons. If it hit an ice sheet, the meltwater flood would have been biblical, and it might not have been the only impact. Some researchers think there could be other craters still hidden under ice or ocean sediment waiting to be discovered. Now here's the thing. This hypothesis is controversial, really controversial. Half the scientific community finds the evidence compelling. The other half remains deeply skeptical. The critics point out that some of the evidence has been challenged. Not all researchers have found nanodiamonds in the boundary layer. The dating isn't always consistent. The Hiawatha crater might be older or younger than proposed. These are legitimate concerns, the kind of rigorous questioning that makes science work. But the proponents keep finding more evidence. More impact proxies, more unusual materials, more sites showing signs of catastrophic disruption right at the boundary. The debate continues, papers published, conferences held, fieldwork conducted. This is science happening in real time, wrestling with evidence that doesn't fit neatly into existing models. What we can say is this: something extraordinary happened 12,900 years ago. Whether it was one large impact, multiple smaller ones, or something else entirely, the evidence demands explanation. And if the impact hypothesis is even partially correct, it means the end of the Ice Age wasn't just a story of gradual climate change. It was punctuated by fire from the sky, by catastrophe on a scale that would have seemed like the end of the world to anyone who witnessed it. Maybe it was. Here's something that should make you pause. Nearly every ancient culture on Earth, from Mesopotamia to Mexico, from India to Iceland, tells a story about a great flood. Not just any flood. The flood. The one that destroyed the world and drowned almost everything. These stories are so widespread, so consistent in their basic elements, that for centuries scholars dismissed them as mere coincidence. Religious mythology. Primitive attempts to explain natural disasters. But what if they weren't just myths? What if scattered across these ancient tales, preserved in the oral traditions of peoples separated by thousands of miles and thousands of years, there are genuine memories of something that actually happened? Something catastrophic. Something world-changing. Something that occurred right around the time the Ice Age ended. Let's start with the most famous flood story, Noah's Ark. Everyone knows the basics. God decides to wipe out humanity because of their wickedness. He tells Noah to build a massive boat and load it with animals 2 by 2. The rains come for 40 days and nights. The whole world floods. Everything dies except what's on the ark. Eventually the waters recede and Noah's family repopulates the earth. It's a good story. But here's the thing. It's not original. The biblical account was written down around 600 BCE, but it's clearly based on much older stories from Mesopotamia. The Epic of Gilgamesh, written more than 4,000 years ago, contains a flood narrative that's remarkably similar. In that version, the gods decide to destroy humanity with a flood. But one god warns a man named Utnapishtim, tells him to build a boat, save his family and animals. The flood comes, covers the earth, kills everything. Utnapishtim's boat eventually grounds on a mountain. He sends out birds to find dry land. Sound familiar? But it gets better, or weirder, depending on how you look at it. The Mesopotamian flood story wasn't original either. It was based on even older Sumerian tales, some dating back more than 5,000 years, and those stories describe the flood not as divine punishment, but as a natural catastrophe so massive it nearly ended human civilization. They describe waters rising from the ocean, covering the plains, drowning cities. They describe survivors fleeing to the mountains, watching their entire world disappear beneath the waves. Now, you might think this is just ancient Middle Eastern mythology spreading from culture to culture. But flood myths aren't limited to Mesopotamia. They're everywhere. In ancient Greece, the story of Deucalion describes how Zeus decided to destroy humanity with a great flood. Deucalion and his wife Pyrrha build a boat, survive, repopulate the earth. In Hindu tradition, Manu is warned by a fish about an impending flood. He builds a boat, survives, becomes the father of the next generation of humanity. In Chinese mythology, Gun and Yu battle a great flood that threatened to destroy civilization. But it's not just the old world. Native American tribes across North and South America have flood stories. The Ojibwe tell of waters covering the earth until Nanabojo recreated the world. The Inca preserved stories of a great flood sent by the creator god Viracocha. The Aztecs believed the world had been destroyed by water before the current age began. In Australia, Aboriginal peoples tell of a time when the sea rose and drowned the coastal lands, forcing their ancestors to flee inland. In Polynesia, nearly every island culture has stories of great floods that reshaped the world. These aren't vague similarities, They're remarkably specific. Waters rising rapidly, people fleeing, most of humanity drowning, survivors in boats or on mountains, the old world destroyed, a new one beginning. You could dismiss one or two of these as coincidence, maybe even a dozen, but we're talking about hundreds of cultures separated by vast distances, with no contact with each other, all telling essentially the same story. For most of modern history, scholars explain this away. Floods are common disasters. Of course, ancient people would tell stories about them. Of course, those stories would share basic elements. But recent discoveries are forcing us to reconsider, because we now know that at the end of the Ice Age there were actual floods, not ordinary floods, mega floods, catastrophes so massive they literally reshaped continents. Start with glacial lake Agassiz. At the height of the last glacial maximum, enormous ice sheets covered much of North America. As these sheets melted, meltwater collected in vast lakes held back by ice dams. Lake Agassiz, centered in what's now Manitoba, was larger than all the modern Great Lakes combined. For thousands of years, ice dams held this water back. Then, around 13,000 years ago, those dams began to fail. When an ice dam breaks, it doesn't crack slowly. It collapses catastrophically. Imagine a wall of water hundreds of feet high, carrying thousands of cubic miles of meltwater, roaring across the landscape at speeds that would make a tsunami look gentle. That's what happened when Lake Agassiz drained, multiple times. The largest drainage event dumped so much fresh water into the North Atlantic that it disrupted ocean currents and may have triggered the younger Dryas cold snap. Then there were the Missoula floods. Another massive glacial lake, this one in what's now Montana, dammed by ice from the Cordilleran ice sheet. When that dam broke, approximately every 40 to 80 years for several thousand years, walls of water up to 400 feet high carved through the Pacific Northwest. These floods moved water at a rate 10 times the combined flow of all rivers on Earth today. They created the channeled scablands in Washington state, a landscape so bizarre that geologists initially refused to believe it had been shaped by water. The evidence was simply too extreme to be believable. But the megafloods weren't limited to North America. The Black Sea deluge hypothesis suggests that around 7,600 years ago, the Mediterranean Sea broke through a natural dam at what's now the Bosphorus Strait. Salt water poured into the Black Sea basin, which had been a freshwater lake, raising its level by hundreds of feet. Coastal settlements that had existed for millennia were drowned in a matter of days or weeks. If there were people living around that lake, and there certainly were, they would have watched their entire world disappear beneath rising water. That's not mythology. That's Tuesday afternoon turning into apocalypse, and these are just the floods we can prove happened. As the ice sheets melted over thousands of years, global sea levels rose approximately 400 feet. Think about that for a moment. 400 feet. That's a 40-story building. Everything below that line, gone, drowned, erased from the map. Here's the thing about early human settlements. We build near water, rivers, lakes, coastlines. That's where the resources are. That's where life is easiest. During the Ice Age, when sea levels were 400 feet lower, the coastlines were completely different. Vast areas that are now underwater were prime real estate. The Persian Gulf was a river valley. The English Channel was dry land. Between Asia and Australia, there were land bridges and shallow seas with countless islands. People lived there, built there, developed cultures there. Then the ice melted. Over a period of thousands of years, the ocean rose. Slowly in some centuries, catastrophically fast in others, especially when ice dams failed and glacial lakes drained. Communities that had existed for generations watched the water creep closer year by year. Then one day, maybe after an ice dam broke somewhere far away, The sea didn't creep. It surged. It roared inland. It drowned everything. If you survived that, what story would you tell your children? What warning would you preserve? You'd tell them about the flood, the Great Flood, the one that destroyed the world. You'd tell them about the waters rising, the old lands drowning, the desperate flight to higher ground. You'd make sure they never forgot because it might happen again. Those stories would be passed down, generation to generation, changing details, acquiring religious meaning, becoming myth. But at their core, preserving a real memory of real events, events that reshaped the world and nearly destroyed early human civilization. So when you read about Noah, or Gilgamesh, or Manu, or Deucalion, or the hundreds of other flood heroes from cultures around the world, maybe you're not reading pure mythology. Maybe you're reading history. Distorted, mythologized, religiously interpreted history. But history nonetheless. The preserved memories of people who watched their world drown and somehow survived to tell about it. The ocean rose 400 feet. It had to go somewhere. And somewhere was exactly where people were living. By the time the Ice Age was drawing to a close, the world was full of giants. Not mythical ones, real ones. Animals so massive and strange that if you saw them today you'd think you'd stepped into a fantasy novel. In North America alone, there were towering mammoths with curving tusks longer than you are tall. Mastodons, their forest-dwelling cousins, browsing through ancient woodlands like living bulldozers. Giant ground sloths the size of small elephants, rearing up on hind legs to strip entire trees bare. Herds of wild horses and camels, yes, camels, roaming plains that would one day be Kansas and Alberta. There were predators to match them. Saber-toothed cats with dagger-length fangs. Dire wolves, bulkier and more powerful than modern wolves built for tackling big prey. American lions, larger than any living big cat. And the short-faced bear, an apex predator so tall it could look a person in the eye while standing on all fours. This wasn't a fringe ecosystem. It was the dominant one. For hundreds of thousands of years, these animals had survived brutal glacial advances and retreats, shifting grasslands and forests, droughts and floods. They were the normal inhabitants of the late Pleistocene world. And then, in what amounts to an instant in geological time, they were gone. If you could float above North America around 13,000 years ago and slowly let time run forward, you'd watch a whole continent empty out. One by one the giants would flicker and fade, mammoths vanish from the tundra, mastodons disappear from the forests, the great sloths, the saber-tooths, the dire wolves, the American lions, the short-faced bears, all gone. By the time the Holocene, our current warm period, is fully underway, roughly 3/4 of all large mammal species in North America have vanished. 75%. Imagine losing 3 out of every 4 big animals you know. No elephants, no bison, no giraffes, no hippos. The world would feel wrong, empty in a way you couldn't quite put into words. That's what happened at the end of the Ice Age, and no one fully agrees on why. For decades, the most straightforward explanation was climate. The Ice Age ended, temperatures rose, ecosystems shifted, and the giants, adapted to colder conditions, simply couldn't keep up. The story makes intuitive sense. As the glaciers retreated, the vast steppe tundra, the mammoth steppe that had supported huge herds of grazing animals, broke apart into smaller, more fragmented habitats. Forests replaced open grasslands in some regions. Wetlands dried up or moved. For a giant herbivore that needed enormous amounts of food every day, small changes in plant communities could be catastrophic. For the predators that depended on those herbivores, the impact would cascade. Fewer mammoths meant fewer hunting opportunities for saber-toothed cats and dire wolves. Starvation doesn't leave many fossils, but its effects ripple through entire food webs. But there's a problem with the climate-only story. These animals had already survived multiple glacial cycles. Over the last few million years, Earth's climate swung in and out of ice ages again and again. Ice sheets advanced, retreated, advanced, retreated. Temperatures rose and fell by similar amounts. Yet the mammoths, mastodons, ground sloths, and their predators made it through all of those earlier shifts. So why did they suddenly fail this time? That question leads to the second major explanation. Us. By the time the last glacial period was ending, humans had spread into the Americas. Whether they came in a single pulse or multiple waves is still debated, but by around 13,000 years ago, human hunters were definitely on the landscape, carrying sophisticated stone spear points and hunting big game. The overkill hypothesis argues that these newly arrived hunters were simply too effective. The megafauna had evolved with predators, but not predators like this. Coordinated, tool-using, highly social hunters capable of planning ambushes, tracking herds over long distances, and communicating complex strategies. In this view, the extinction was essentially a planetary-scale hunting accident. Humans targeted the biggest, most calorie-rich animals first, mammoths, mastodons, giant sloths, and the populations collapsed faster than they could reproduce. Once the main pillars of the ecosystem fell, the predators and scavengers that depended on them followed. Saber-toothed cats without mammoths are like orcas without whales. Specialists suddenly stranded in a world that no longer fits them. There's evidence to support this. Archaeological sites across North America show mammoth and mastodon bones with cut marks, stone spear points embedded in ribs, clear signs of butchery. Some sites contain the remains of dozens of animals in layers, as if hunting events or mass die-offs happened repeatedly in the same place. But overkill has its own puzzles. Human populations were still relatively small. Could scattered bands of hunters really wipe out entire species across a whole continent in a few thousand years? And if humans were solely to blame, why did some megafauna survive? Bison made it. Moose and deer made it. In Africa, where humans had been present for far longer, many large animals survived the end of the Ice Age relatively intact. That brings us to a third idea, more controversial, more dramatic, and for many people, more compelling: catastrophe. Some researchers argue that something extraordinary happened around the end of the Younger Dryas, that brief, sharp return to near-glacial cold. A cosmic impact. Maybe a swarm of comet fragments or an airburst from a disintegrating object in the atmosphere. Not necessarily a dinosaur-killing asteroid, but something powerful enough to set vast areas on fire, disrupt climates, and stress ecosystems already on the edge. Here the evidence becomes stranger, and the debate more heated. At certain sites dated to this period, researchers have found layers rich in microscopic spherules, tiny glassy beads that can form under intense heat. There are magnetic grains, traces of high-temperature processes, and in some cases charcoal layers suggesting widespread burning. At a few locations there are mass death assemblages, piles of animal bones jumbled together in ways that suggest sudden, catastrophic mortality rather than slow, natural attrition. Some mammoth and mastodon remains show signs of rapid burial, as if overwhelmed by floodwaters or sediment slumps triggered by abrupt landscape changes. Others appear in deposits that hint at violent events, tangled skeletons, disarticulated bones, mixed species all thrown together. Taken individually, none of these pieces are conclusive. Taken together, they suggest that the end of the Ice Age might not have been a gentle thaw, but a period of instability, with abrupt cold snaps, sudden warming, wildfires, floods, and possibly, just possibly, something falling from the sky. Most scientists now lean toward a compromise. Not climate alone, not humans alone, not catastrophe alone, but a perfect storm. Imagine you're a mammoth at the very end of the Pleistocene. The climate is flickering, warm, then cold, then warm again. The plants you rely on are shifting north, then south, then changing species entirely. New predators have arrived on the scene, small, fragile-looking but strangely dangerous. They can kill you from a distance with stone-tipped spears. They cooperate in ways no other predator does. They remember where your herd crossed the river last year. Now add in a few bad years, maybe a severe drought, maybe a sudden cold snap, maybe an intense fire season set off by dry lightning, or by fragments of a comet exploding in the upper atmosphere, igniting forests and grasslands in minutes. Your world, already precarious, becomes unlivable. Birth rates drop. Calf mortality rises. One harsh winter wipes out the weakest. One flood drowns entire herds in a single day. None of these factors alone has to be apocalyptic, but together they push populations below the point of no return. Once the numbers get too low, chance takes over. A bad year in one valley, an epidemic in another, a group of efficient hunters in a migration corridor, and that's it. The last mammoth in that region dies, and the line snaps forever. From our vantage point, tens of thousands of years later, we see only the absence, the empty niches, the bones in caves and riverbanks, the scattered clues that something enormous happened at the boundary between the world of ice and the world we know. We can measure the losses, we can map the timing, we can argue about causes, but we can't fully recover what it felt like to live alongside those giants, or what it meant to watch them vanish. What we can say is this: the end of the Ice Age wasn't just a story of melting glaciers and rising seas. It was a mass extinction, a silent apocalypse that reshaped entire continents. It cleared the stage for a new kind of world, one where the largest, most adaptable predator left standing was us, and in the newly emptied landscapes, with the shadows of the giants still fresh in cultural memory, other possibilities began to emerge. Civilizations, perhaps, stories of floods and fire, myths of lost worlds that might, just might, remember more than we think. By the time the last ice sheets began to melt in earnest, your ancestors were no longer the desperate survivors of a genetic bottleneck. They were expert foragers, skilled hunters, clever toolmakers. They understood seasons, animal migrations, plant cycles. They had language rich enough to teach, remember, and imagine. So now imagine this. Tens of thousands of years pass. People keep learning. They keep experimenting. They keep telling stories and improving tools. Generations stack on top of generations like layers of sediment. Do you really think nothing surprising happened in all that time? This is where the story steps out of the comfort of settled science and wanders into the twilight zone between what we know and what we suspect. Some researchers, and a lot of curious minds, ask a simple but unsettling question. What if humans, or human-like cultures, built something complex before the official start of civilization? What if an advanced culture rose during the late Ice Age, and then disappeared when the world changed? Mainstream archaeology is cautious here. The standard timeline says large-scale civilization, cities, writing, organized states, begins around 6,000 years ago in places like Mesopotamia, Egypt, and the Indus Valley. Before that, we're told, people were mostly scattered bands of hunter-gatherers, slowly experimenting with farming. But every so often we dig up something that doesn't quite fit the diagram in the textbook. On a windy hilltop in southeastern Turkey, beneath layers of soil deliberately piled up by ancient hands, lies one of those anomalies, Göbekli Tepe. When it was first excavated in the 1990s, archaeologists expected a simple prehistoric campsite. Instead, they found stone circles, massive T-shaped pillars, carvings of animals, lions, snakes, vultures, etched with a skill that speaks of long practice and shared symbolism. And then came the radiocarbon dates, about 11,600 years ago, right at the end of the Younger Dryas cold snap, thousands of years before the pyramids, thousands of years before Stonehenge, and crucially, before the conventional birth of agriculture in that region. According to the standard story, you invent farming first, then surplus food lets you build temples and monuments later. Göbekli Tepe flips that logic on its head. Here, it looks like people may have built a monumental ritual site while still primarily hunter-gatherers, then figured out farming afterward. The stones suggest planning, coordination, shared beliefs, knowledge of quarrying and moving multi-ton blocks. This isn't something a random group throws together between hunting trips. This feels like the work of a culture, a complex one. No one is claiming they had computers or steel or skyscrapers. Advanced here doesn't have to mean modern. It can mean socially and symbolically sophisticated, capable of organizing large labor forces, capable of aligning structures with stars or solstices, capable of remembering stories so important they were carved into stone. And Göbekli Tepe isn't sitting alone in time. It appears exactly where our earlier story left off, on the far side of the Younger Dryas. Right after a period of climate chaos that may have erased entire ways of life. If a culture existed before that cold snap, if it lived along the shores of Ice Age coastlines, much of its physical footprint would now be underwater. At the coldest point of the last Ice Age, sea levels were more than 100 meters lower than today. Coastlines stretched far out into what are now continental shelves. Broad plains lay where the ocean surface now sparkles. Those were prime real estate. Mild coastal climates, abundant marine life, rivers flowing out across now submerged valleys. If you were going to build early villages, you might build them there. And when the ice melted, the water would rise, quietly, relentlessly, century after century until your world was gone. This is why some researchers think our picture of prehistory is fundamentally incomplete. Most of the places early complex societies might have favoured are now drowned. We've only really explored a tiny fraction of the seafloor, and almost none of it with archaeology in mind. Every now and then, however, something under the waves catches our attention. Off the coast of Japan, near the island of Yonaguni, divers discovered a series of stepped terraces and massive stone formations, sharp edges, right angles, what looks at first glance like a submerged pyramid or temple complex. Some geologists argue Yonaguni is purely natural, sandstone fractured by tectonic forces and erosion into strangely geometric shapes. Others note what appear to be flat platforms, stair-like steps, and clean vertical faces, and wonder if human hands help shape what nature began. If it is artificial, it would have to date back to a time when sea level was much lower, possibly late Ice Age. Far away in the Gulf of Cambay off the western coast of India, sonar surveys in the early 2000s revealed patterns on the seafloor that looked suspiciously like city grids, rectilinear structures, possible street plans, even what some claimed were artifacts brought up from the depths. A few enthusiasts hailed it as a drowned Ice Age metropolis. Mainstream researchers urged caution. Dating undersea finds is hard. Objects can be moved by currents. Natural formations can mimic human layouts when viewed by low-resolution sonar. The debate fizzled without a clear consensus. The site remains more question than answer. In the Mediterranean, from the submerged ruins of Pavlopetri in Greece to mysterious stone alignments off Malta and possible harbour works off Israel, we find similar puzzles. Some of these sites are clearly Bronze Age settlements swallowed by later sea level rise and subsidence. Others are more ambiguous, rock formations that might be natural, might be modified. In each case, mainstream archaeologists lean towards simpler explanations: erosion, tectonics, later historical flooding. They point out correctly that extraordinary claims need extraordinary evidence. One blurry sonar map or a few oddly shaped stones aren't enough to rewrite the human story. But the anomalies keep showing up. A carved block here, a suspicious alignment there. Enough to keep curiosity alive. Into this space of tantalizing hints steps a popular, controversial voice. Graham Hancock. Hancock argues that during the late Ice Age there may have been a sophisticated global culture, or at least a network of advanced coastal societies. According to his theory, these people understood astronomy, navigation and geometry to a far higher degree than we usually credit to Ice Age humans. In his telling, the Younger Dryas wasn't just a climate event, it was a civilization killer. Comet fragments or meteor impact triggered wildfires, floods, global temperature shocks. The great ice sheets destabilized. Sea levels rose. Most of this hypothetical civilization, built along low-lying coasts, vanished beneath the ocean. What survived? Myths, star lore, architectural traditions. Hancock suggests that sites like Göbekli Tepe and later megalithic structures worldwide are the work of survivors or inheritors, people rebuilding, remembering, or imperfectly copying what a lost culture once knew. It's a compelling story. It stitches together flood myths from Mesopotamia, Plato's tale of Atlantis, and worldwide traditions of a time when the gods, or culture bringers, taught humans agriculture, astronomy and architecture. Mainstream archaeology remains deeply skeptical. There is, they point out, no clear, unambiguous evidence of an Ice Age civilization on the level of Egypt or Sumer. No definite cities, no writing, no metallurgy from that period. Göbekli Tepe is impressive, but it's still stone, still Neolithic, still compatible with gradual local development. Yonaguni and Cambay, they say, are too uncertain, too poorly dated. And yet, even many cautious researchers will admit there are gaps. There are places we haven't looked, entire drowned landscapes we've barely mapped, much less excavated, and there are cultural leaps, like the sudden appearance of monumental architecture, that feel abrupt, as if we're missing the earlier chapters of a long story. So the question lingers in the quiet hours. If rising seas could swallow entire continental shelves, if 1,000 years of storms and currents could grind coastal cities to sand, what would we actually expect to find 12,000 years later? Stone anchors, perhaps, carved blocks dislodged and scattered, odd terraces on the sea floor, a handful of artifacts scooped up in fishing nets, myths of a world before the flood, preserved in stories, songs and sacred texts. Maybe that's all that's left. Or maybe we haven't yet looked in the right places with the right tools for long enough. For now, the idea of a lost Ice Age civilization sits in a strange limbo. Not proven, not impossible. A theory waiting in the dark like a ruined city just beyond the range of our dive lights. What we can say with confidence is this. When the ice melted and the oceans rose, they didn't just reshape coastlines. They erased entire landscapes where humans had lived for tens of thousands of years. Whatever those people built, loved, and remembered, much of it now lies beneath the waves. The story of our species may be far older and far stranger than the version carved into classroom timelines. And as the water quietly laps against today's shores, it hides a past we're only beginning to imagine. So now zoom in, not on ice sheets or mammoths, but on something much smaller. A single human camp. A ring of firelight in a world that has just been turned upside down. The great ice sheets are melting. Sea levels are rising like a slow, unstoppable tide. Huge lakes are bursting their banks, sending walls of water racing across the land. The climate is lurching from warmth to sudden freeze and back again in the space of a few human lifetimes. The Younger Dryas has slammed the planet into a kind of climate whiplash, and no one knows if the next season will bring gentle rain or famine. Somehow, in the middle of all this, your ancestors survived. Genetic evidence suggests that during this period, human populations went through another squeeze, not as extreme as the ancient bottleneck that forged our species, but a tightening all the same. A dip in genetic diversity, a sign that numbers fell, that some branches of the human family tree withered, while others somehow held on. You can almost picture it. Small bands watching the weather shift in ways their elders had never seen. Herds changing their migration routes, rivers carving new channels as meltwater roared through ancient valleys. Some groups stayed put and vanished from the record. Others began to move. This is where the story of migration becomes a survival strategy. As the ice retreated north, corridors of green opened up. New grasslands, new coasts, new river valleys. Human groups followed, not as neat arrows on a map, but as hesitant stop-and-start journeys. A few families pushing into a new valley, testing it for a season, then retreating or calling more kin to join them. Over generations, these small experiments in movement turned into great population shifts. Archaeologists see this not in dramatic monuments, but in little clues, a style of stone tool that suddenly appears hundreds of kilometers away from its original homeland. Shell beads from the coast turning up deep inland. Genetic markers drifting across regions like faint fingerprints in the DNA of later peoples. Together they tell a quiet story of bands on the move, feeling their way through a world that wouldn't hold still. To stay alive in such a world, you needed more than courage. You needed new ways of making a living. During the height of the Ice Age, many humans relied on big game hunting, following huge herds of reindeer, mammoth, bison. When the climate lurched and the megafauna began to disappear or shift their ranges, that strategy stopped working. In some regions, it became a death trap, so people adapted. Hunting changed from chasing a few giant animals to managing many smaller ones. Instead of staking everything on one perfect spear thrust into a mammoth, you learned to trap dozens of hares, birds, and gazelles. You developed lighter, more precise projectiles. Microliths. Tiny, razor-sharp stone blades set into wood or bone shafts. A single spear point became a composite technology. Interchangeable parts, easy to repair, easy to customize. Fishing took on new importance. As meltwater rivers braided and spread, fish became moving packets of protein. Nets, hooks, harpoons, simple by our standards, revolutionary by theirs, turned rushing water into a food source you could depend on, at least more than the vanishing giants of the Ice Age. And then there was the most radical survival strategy of all. Not just taking what nature gave you, but nudging it, guiding it, eventually reshaping it. Before full-blown agriculture appeared, something subtle emerged in the Levant, along the eastern edge of the Mediterranean. A culture we now call the Natufians. Imagine their world. Rolling hills, wild stands of wheat and barley swaying in the wind, oak and pistachio trees scattered across the landscape. Not the harshest edge of the Ice Age, but a relatively gentle refuge caught between extremes. Here, around 15,000 years ago, people did something strange. They began to stay put. Natufian sites show permanent or semi-permanent stone houses, grinding stones worn smooth by years of use, pits for storing seeds and nuts. Tools specialized for cutting cereals. They hunted and foraged, yes, but they also began to rely heavily on wild grains. Instead of wandering endlessly, they anchored themselves near rich patches of food and came back season after season. This was not yet farming. No ploughs, no rows of planted fields, but it was a psychological shift, a new agreement with the land. If we stay here, if we learn this place deeply enough, it might keep us alive. You can almost feel the logic forming around the campfire. The climate has just proven it can swing wildly. Herds can vanish, rivers can shift, but plants, if you scatter seeds where you want them, maybe next year there will be food right here. If you store grain in stone-lined pits, maybe the next sudden freeze won't kill your children. Over time, this cautious relationship with wild plants deepened. People began to prefer grains whose seeds didn't shatter and blow away. They harvested in ways that favored certain traits without knowing anything about genetics. The plants that were easiest to gather became the ones that spread. Slowly, in the hands of anxious survivors, wild grasses turned into domesticated crops. Other groups in different regions were taking parallel steps. In Anatolia, in the Zagros Mountains, along the Nile, in parts of China and Mesoamerica later on. Small experiments in tending, planting, tethering animals. Transitional societies bridging the gap between Ice Age foragers and settled farmers. But beneath all these practical changes, something else was evolving. The inner landscape. The realm of story and belief. When you live through repeated catastrophe, sudden freezes, strange floods, fire raining from the sky, coastlines drowning within the memory of your grandparents, it changes how you see the world. The universe stops feeling stable or predictable. It begins to feel temperamental, capricious, powerfully alive. Many researchers think this is when early religious ideas began to crystallize in new ways, not just vague awe at the sun or the hunt, but more structured attempts to explain why the world could be so kind one generation and so cruel the next. You can imagine stories taking shape. Once the sea was far away, then the waters rose to punish us. Once the sky was calm, then something burned across it and the animals died. Once the winter ended on time, then a great cold came back and would not leave. Over time, such memories turn into myths. Myths turn into rituals. You bury your dead with care, maybe to ensure they're on your side in whatever invisible realm lies beyond. You build shrines or special places, align stones with the rising sun, as if trying to reassure yourself that at least the heavens still follow some kind of pattern. There's a provocative idea that sits at the intersection of archaeology and psychology, the theory that catastrophic memories didn't just shape beliefs, they pushed us into civilization itself. In this view, agriculture and permanent settlements weren't simply clever new technologies. They were a collective coping mechanism, a hedge against a universe that had revealed how dangerous it could be. If the ice can return overnight, you stockpile grain. If seas can swallow coastlines, you build your houses on higher ground and make them out of stone. If the animals can vanish, you domesticate a few and keep them behind your walls. Permanent villages, storage pits, granaries, animal pens, they're all ways of saying, never again, we will not be caught unprepared. We can't know exactly what was in the minds of Natufian elders or the first farmers at Jericho, Sat al-Hoyuk, or the early Nile villages. But the timing is suggestive. Again and again, the archaeological record shows a pattern. Extreme climate instability, followed by an upsurge in settlement, storage, symbolic behavior, and eventually organized agriculture. It's as if the shock of nearly losing everything jolted human societies into a new mode. Less flexible, perhaps, more rooted, but also, in a strange way, safer. A bet placed on predictability, even in a world that had just proven itself wildly unpredictable. And so, the survivors of the Younger Dryas did what their distant bottleneck ancestors had done long before. They adapted not just with their bodies, but with their minds, their tools, their stories. They turned fear into planning, trauma into tradition, memory into architecture. When you lie down to sleep tonight, your brain, your culture, your entire civilization rests on that foundation, on the quiet, stubborn resilience of people who watched the old Ice Age world die, and refused to die with it. But their story, like all good stories, leaves traces. Fossils, artifacts, myths, genes. And if you follow those traces carefully enough, they lead somewhere surprising, into the evidence trail that scientists are still piecing together, clue by fragile clue. If you zoom out from the lives of those Ice Age survivors and look at the planet itself, something strange begins to happen. The Earth turns into an archive, ice becomes a library, mud becomes a diary. Even the air trapped in ancient bubbles starts whispering its secrets. And over the last few decades, scientists have been learning how to read those whispers. The most important pages in that planetary archive are buried deep under Greenland and Antarctica. Imagine drilling 2 miles straight down through ancient ice, cylinder after cylinder, each one a frozen time capsule. Every layer is a winter's worth of snowfall gently compressed over thousands of years, stacked like pages in a book that no one knew how to read until very recently. When researchers brought those cores to the surface and started analysing them, they found something astonishing. The end of the last ice age didn't unfold as a slow, gentle thaw. In the Greenland ice, you can see temperature lines that look less like a smooth curve and more like a heart monitor gone wild. Long stretches of cold, then sudden spikes of warmth, followed by brutal plunges back into deep freeze. In some places, the chemistry of the ice suggests temperature jumps of 5 to 10 degrees Celsius in just a few decades. Within the span of a human lifetime, entire climate zones shifted. Grasslands turned to forest. Forests shrank back to tundra. Rivers changed their courses. Animals scrambled to follow the ecosystems they depended on. For people living through it, the world wouldn't have felt stable. It would have felt twitchy, nervous, ready to flip from one state to another with very little warning. One generation might remember abundant herds and mild summers. Their grandchildren might grow up knowing only hunger and ice-edged winds. The ice cores show that this wasn't imagination. The climate really was that jumpy. Stacked within those frozen layers are tiny bubbles of air, trapped at the moment the snow fell. By analysing the gases inside them, carbon dioxide, methane, even traces of ancient smoke, scientists can actually reconstruct how the atmosphere changed as the Ice Age ended. You can see pulses of greenhouse gases, sudden surges of methane that might reflect vast wetlands thawing, or enormous fires burning through newly dried landscapes. Some spikes line up with mysterious layers of dark material in the ice, microscopic bits of charcoal, tiny glassy spherules, particles that look suspiciously like they were born in fire. Some researchers trace these to wildfires. Others argue they might be fingerprints of impacts or airbursts or other high-energy events. The evidence isn't yet conclusive, but it's consistent with a world that wasn't just warming and cooling. It was flaring, shaking, burning. The ice tells us what the planet was doing. Our DNA tells us what people were doing. Every cell in your body carries a record of where your ancestors went and what they survived. Not a written record, but a statistical one. Patterns in your genes that only make sense if certain things happened at certain times. When geneticists began sequencing DNA from people across the globe, and later from ancient bones and teeth, they found echoes of those same Ice Age stresses. Traces of population collapses that look like bottlenecks. Periods where the number of humans alive dropped sharply, then slowly recovered. You can see it in the reduced diversity of certain gene families, in the way particular variants spread rapidly from small isolated groups to entire continents. Some of those genetic scars line up with known climate crises. Sudden cold snaps, mysterious droughts, times when the ice cores say the world lurched, times when humans, already scattered and vulnerable, suddenly had to move, adapt, or die. You can also see waves of movement. During the late Ice Age, small groups left their refuges and pushed into newly opened lands. A handful of successful lineages expanded massively. their genetic signatures washing over older ones like fresh paint over a faded mural. But the older traces never entirely vanished. They linger as ghostly fragments in modern genomes, reminders that the story of humanity wasn't a single march forward, but a tangle of expansions, crashes, and minglings. The more ancient DNA we recover, from caves in Europe, frozen ground in Siberia, rock shelters in Africa, the more complicated the picture becomes. Neanderthal genes showing up where they shouldn't be. Denisovan genes appearing in populations thousands of miles from the few fossils we've actually found. Unknown ghost populations implied by genetic patterns that don't match any known group. The end of the Ice Age didn't just sculpt the land, it sculpted us. While geneticists and ice core scientists were untangling these lines of evidence, archaeologists were quietly rewriting the timeline of human achievement. For a long time, the story went like this. Humans were simple hunter-gatherers through most of the Ice Age. Then suddenly, when the climate warmed and the glaciers retreated, we invented agriculture, built villages, and started making complex monuments. But in the last few decades, spades and trowels have been telling a different story. Sites like Göbekli Tepe in modern Turkey show massive stone circles, carefully carved pillars weighing tons, built more than 11,000 years ago, right as the Ice Age was ending, and crucially, before full-blown farming took hold in that region. Other sites around the world are pushing back dates for complex toolkits, long-distance trade in obsidian or shells, and surprisingly sophisticated art. In some places, hunter-gatherers were building permanent or semi-permanent structures earlier than anyone expected, storing food, returning to the same places season after season, investing effort in architecture, in ritual spaces, in shared projects that must have required coordination and leadership. Each new discovery chips away at the old picture of simple Ice Age humans, waiting passively for the Holocene. Instead, it looks more like people were experimenting constantly, trying out agriculture in one valley, abandoning it in another, building monumental sites here, living lightly on the land there. The end of the Ice Age isn't a clean break. It's a messy, creative transition filled with false starts and regional variations. Beneath all of this, literally, there's the mud. Around the world, lakes, ocean floors, and river deltas are layered with sediments laid down year after year. When scientists core those sediments, they find thin bands, sometimes just a few millimeters thick, where something dramatic happened. Some layers are rich in charcoal, hinting at periods of widespread burning. Others contain tiny glassy droplets that form at extreme heat, or elevated levels of elements associated with cosmic material. In some regions, you see sudden shifts in pollen, forests disappearing almost overnight and being replaced by grasses or shrubs. In others, abrupt increases in erosion, as if hillsides were stripped bare in a short, violent episode. Different teams interpret these layers differently. Some see the fingerprints of rapid climate flips alone. Others argue for floods, megafires, even impact events playing a role. The data are patchy, scattered, and often frustrating. But they agree on one thing. The end of the Ice Age was punctuated by episodes of sudden disruption, not just slow, gentle change. When you line up all these strands, the ice cores, the genes, the bones, the buried stones, the mud, the story doesn't become simpler. It becomes stranger, richer, more alive. Instead of a single, neat explanation, you get a living field of research where each new discovery forces everyone to adjust. An unexpected layer of platinum in Greenland ice, a new ancient genome from a forgotten cave, a submerged shoreline revealing stone tools under what is now the sea. Every few months another piece clicks into place and the picture shifts slightly. Scientists debate, models are revised, hypotheses rise and fall. Some ideas that sounded wild a generation ago are now considered plausible. Others that once seemed obvious are slowly being eroded by new data. And somewhere in the middle of all that uncertainty is you, listening in the dark while the planet's deep time memories unfold. The truth is, our understanding of what really happened when the Ice Age ended is still under construction. The evidence trail is long, tangled, and incomplete, but with every core drilled, every genome sequenced, every forgotten site unearthed from beneath ice, forest, or sea, we get a little closer to understanding what our ancestors faced and how they turned catastrophe into opportunity. And in the spaces where the evidence is still thin, that's where the more speculative, more controversial ideas slip in, the ones that speak of lost cultures, forgotten technologies, and civilizations swept away by meltwater and storm. Those are the theories that live at the edge of the map, and that's where we're heading next. Now that we've walked through what the evidence can support, let's dim the lights a little more and step into the borderlands, the place where the facts start to blur at the edges and speculation quietly slips in. Because when people look back at the end of the Ice Age, at the sudden meltwater floods, the vanished coastlines, the mass extinctions, they don't just see geology and climate models, they see a mystery, a puzzle with a few missing pieces. And whenever humans see a mystery, we start telling stories to fill the gaps. Some of these stories are wild, some are thoughtful, a few may even contain fragments of truth wrapped in layers of misunderstanding. None of them are accepted as mainstream science, but they're worth visiting, if only to understand how our imaginations wrestle with deep time. One of the most dramatic ideas is the pole shift theory, not the slow wandering of Earth's magnetic field that scientists can measure and model, but a sudden, catastrophic shift of the entire crust. In this picture, the outer shell of the Earth supposedly slips over the molten interior, like the skin of an orange suddenly sliding around the fruit underneath. In a single geological blink, Antarctica, the story goes, might have moved from a temperate latitude into a polar deep freeze. Lush regions could have been hurled into the Arctic Circle. Ice sheets might not have taken tens of thousands of years to grow, but only centuries, or even less. Proponents of rapid crustal displacement point to maps that seem to show ice-free coastlines of Antarctica, to ancient legends of worlds turned upside down, to sudden climate flips like the Younger Dryas. They imagine a planet lurching on its axis, oceans sloshing out of their basins, continents shuddering into new positions while anything living on the surface just tries not to be erased. Mainstream geophysics has a simple response. We don't see the scars. A shift that dramatic would leave clear, global signatures in the rocks, in the magnetic record, in the orientation of ancient shorelines and coral reefs. And those signatures just aren't there. The crust does move, but on slow, grinding tectonic timescales, not all at once. Still, the pole shift story refuses to die. Maybe because it offers something emotionally satisfying, a single, clean mechanism for chaos. One big event that rearranges everything, a switch you can flip instead of a complex web of slow overlapping processes. Then there's a different family of ideas, less about moving continents and more about moving minds. Theories of ancient advanced technology and lost knowledge. In this version, the end of the Ice Age wasn't just the end of a climate regime, it was the end of a civilization, or several. People imagine cities that once stood on now drowned continental shelves, ports that faced long vanished shorelines, cultures with astronomy, navigation, maybe even forms of engineering that would have looked impossible to the hunter-gatherers who came after. They point to megalithic sites like Göbekli Tepe, which appears suddenly, fully formed, near the end of the Ice Age, to precise stonework in places like Egypt and South America, to global flood myths and stories of gods who taught agriculture and writing, arriving after some earlier catastrophe. The conventional view is cautious. Most archaeologists see these as the products of human ingenuity we already understand. Stone tools, persistent experimentation, social complexity emerging step by steady step. No lasers, no vanished global power grid. Just people, very much like us, working with the materials and knowledge they had. But the lost civilization hypothesis raises a quieter, more reasonable question beneath the dramatic wrapping. How much cultural memory dies when sea levels rise 120 meters? How many coastal settlements, seasonal camps, trade hubs, and ritual sites now lie under tens of meters of water, smeared across muddy continental shelves? We know the ocean has swallowed entire landscapes. We know humans were living near those shifting coastlines. What we don't know, at least not yet, is precisely how organized, how interconnected, or how knowledgeable some of those communities may have been. The idea of advanced technology might be an exaggeration. The idea of lost knowledge probably isn't. Threaded through all of this is a deeper fear and fascination that reaches far beyond the Ice Age. The idea of cycles, that Earth doesn't just have one catastrophe but many, over and over, a kind of cosmic heartbeat you can't feel in a single lifetime, but that echoes across myths and rocks alike. Some people look at asteroid impacts, volcanic super eruptions, magnetic reversals, climate swings, and sea patterns, regular pulses of destruction. They suggest the solar system has cycles of increased debris, that the sun has long rhythms we barely understand, that the galaxy itself might drag us through zones of higher radiation or gravitational instability. In these stories, the end of the last ice age isn't unique. It's just the most recent crest in a long series of planetary mood swings. Science, again, is more restrained. We do see periodicities in some records, ice ages tied to shifts in Earth's orbit, extinction pulses that may correlate with impacts or volcanism. But the data is noisy. The cycles aren't metronomes. They're messy, overlapping tendencies. And even when patterns exist, predicting the next catastrophe is much harder than drawing a neat line through the past. Still, one thing is clear. Earth will face future threats. More impacts will come, even if most are small. Climate will continue to change. Supervolcanoes will eventually erupt again. The question isn't whether the planet is dangerous. It always has been. The question is how we prepare, how we watch the sky, how we monitor the ground beneath our feet, how we decide which risks to take seriously. All these fringe theories, pole shifts, hidden technologies, cyclical cataclysms, share a common thread. They're attempts to make sense of vulnerability, to tell a story about why things fall apart and whether they might fall apart again. They're not supported by the weight of evidence. They're not how working geologists, archaeologists, and astronomers currently explain the end of the Ice Age, but they do something important. They keep us asking questions. They remind us that our picture of the past is still incomplete, that the map of the drowned world is only half drawn, that the universe is bigger and stranger than any single discipline can comfortably contain. So as you drift towards sleep, you can hold two thoughts at once. On one side, the careful incremental work of science, grounding us in what the rocks and bones and ice cores can actually tell us. On the other, the speculative stories that swirl around the edges of that knowledge, inviting us to imagine, to test, to doubt, and to refine. Between them lies a narrow path, open-minded but not gullible, curious but not careless. A path our ancestors have walked since long before the Ice Age ended. A path that leads us from mystery into understanding, one question at a time. So what does all of this have to do with you, lying here in the dark, listening to stories about ice and fire and vanished worlds? More than you might think. Because the end of the last Ice Age wasn't just a chapter in some distant completed story. It was a rehearsal. A preview of what happens when climate turns on a dime, when familiar patterns break, when the world you grew up in quietly stops being the world you live in now. For your Ice Age ancestors, change didn't arrive with headlines or scientific reports. It arrived as a river that didn't freeze when it usually did, as glaciers that stopped advancing and began, almost imperceptibly, to shrink, as new plants creeping into old landscapes, unfamiliar animals appearing at the edge of the forest, tiny shifts year by year that added up to a completely different planet. They didn't know words like climate system or feedback loop. They just knew that the rules were changing. Migration routes that had fed their grandparents no longer worked. Shelters that had been safe for generations suddenly flooded. Coastlines moved. Rivers jumped their channels. Lakes appeared in places that had been dry land for tens of thousands of years. And they had a choice. The same choice we have now, even if it looked different. Adapt or vanish. The archaeological record from the end of the Ice Age reads like a quiet, patient manual on resilience. Toolkits shift as animals migrate. Hunting strategies change as forests replace open steppe. People learn to fish where ice had once covered the water year-round. They experiment with new plants, new ways of storing food, new ways of organizing themselves when game becomes unpredictable. They weren't superheroes. They were scared, confused, often wrong. There must have been years when every decision felt like a gamble. Move north or south, stay by the coast or follow the retreating ice. Trust that the rains will come back, or abandon the valley before it's too late. But under that uncertainty, something deeper was at work. The same traits that were forged in the bottleneck. Cooperation, knowledge sharing, the ability to imagine a world different from the one right in front of you, became the survival toolkit of a warming planet. People who could look at a melting glacier and think, what will this look like in the future, had an advantage. People who could listen to elders' stories about how things used to be and recognize patterns in the chaos, they made better decisions. Climate change for them wasn't an abstract moral debate. It was the shape of the river, the timing of the seasons, the line where the ice ended and the grass began. It was intimate, immediate, undeniable. The lesson is uncomfortable but simple. Our world can transform much faster than feels possible. It has done so many times. It will do so again. The difference now is that we can see it coming. Satellites, graphs, models, they're just elaborate versions of what your ancestors did when they watched the horizon and tried to guess if the rains would fail again. The challenge is the same. Can we cooperate fast enough, share information widely enough, act on knowledge bravely enough to get through the transition with as little suffering as possible? When you zoom out far enough, the end of the Ice Age is a reminder that stability is an illusion. The coastlines that feel permanent, the climates that seem normal, the ecosystems that look ancient and unchanging. Most are temporary arrangements in a restless system. Under the oceans, in the dark and pressure, there are the ghost outlines of old shorelines, submerged forests, river channels that once cut through dry land where waves now roll. Entire Pleistocene landscapes sleep beneath the continental shelves. Campfires, hunting grounds, migration routes, all wiped clean by the rising seas, their stories erased except for a few stone tools pulled from the seabed by chance. How much of our past is still hidden there? When you look at a modern map, it's easy to forget that the shape of the continents is just a snapshot. During the Ice Age, sea level was lower by more than 100 meters. Whole land bridges connected places that are now separated by deep water. Asia to North America, Britain to Europe. Islands joined into broad peninsulas. People walked across regions we can only cross by ship or plane today. Most of those pathways are invisible to us now. The cultures that walked them, the languages they spoke, the knowledge they carried, their traces are probably sealed under silt and sand and coral. We only catch glimpses. a mammoth bone dredged from the North Sea, a stone blade found off a drowned coast, a submerged cave with paintings still clinging to the rock. It's like looking through pinholes in a curtain, trying to reconstruct an entire theatre performance from a few scattered scenes. Future discoveries will pull back that curtain, little by little. Every new sediment core from the ocean floor, every undersea survey, every ancient DNA sequence extracted from a tooth or a fragment of bone has the potential to rewrite this story, to shift dates, to move migration routes, to reveal that what we thought was impossible was happening quietly on some lost shoreline for thousands of years. Maybe we'll find evidence of dense coastal societies along now sunken plains, people who mastered fishing and seafaring long before we think civilization began. Not lost super cities of myth necessarily, but complex, resilient communities whose ruins now lie under 50 meters of water. Or perhaps we'll uncover new human branches, cousins we never knew we had, their genetic traces still flickering faintly in living populations. There are enduring mysteries that refuse to settle. Why did some megafauna vanish while others survived? Why did Neanderthals, with their powerful bodies and big brains, disappear while our lineage persisted? How many times did humans reach the Americas, and by what routes? How much knowledge, how many myths and techniques and stories were carried along coastlines now erased by the sea? Possibilities range from the sober and scientific to the quietly strange. Maybe there were maritime cultures that paddled the edges of Ice Age continents, following fish migrations and seabirds, leaving only subtle signatures in the genetics of coastal peoples. Maybe memories of the rising seas, of flooding valleys and swallowed plains, condensed over millennia into the flood traditions found from Mesopotamia to Polynesia. We can't know the full picture yet. We might never know all of it. But lying here, you're connected to that hidden world in a very real way. The blood moving through your veins is the same bloodline that watched ice walls glitter in the pale sun and wondered if spring would come. The brain that's drifting towards sleep is built from the same neural circuitry that tracked game across thawing tundra, that memorized river crossings, that told stories by firelight about the world before the melt. You are, in a literal, biological sense, a message in a bottle sent across the end of the Ice Age, a living archive of choices, adaptations, and narrow escapes. Every heartbeat is proof that the experiment didn't fail, that the survivors made it through the chaos, that they found ways to live in a planet that wouldn't stop changing under their feet. The end of the Ice Age is not just a tale of glaciers and mammoths. It's a reminder that our planet is dynamic, that apparent stability is woven out of constant motion, and that humans are at our best not when the world is easy, but when we learn, cooperate, and imagine our way through crisis. Somewhere, beneath the waves and under the ice and buried in forgotten caves, there are still chapters of this story waiting to be read. New fossils, new artifacts, new genetic clues. And as those pieces surface one by one, our picture of who we are and how we got here will keep shifting, just like the shorelines, just like the climates, just like the night sky your ancestors watched as the last great ice sheets melted away. So now, as your eyes grow heavy and the room around you settles into quiet, you're lying at the far end of a very long story. You've walked from a world locked in ice, seas pulled back from the coasts, mammoths and mastodons tracing paths across frozen ground, all the way to the first sparks of what we'd recognize as civilization. Fields being planted, villages forming, stories being told around new kinds of fires. We've followed the trail of clues, craters and charcoal, meltwater floods and vanished shorelines. We've listened to glaciers cracking, comets possibly falling, and oceans rising over lost river valleys where people once may have lived, loved, and disappeared beneath the waves. We've watched human beings thread their way through catastrophe, turning fire, stone, and memory into survival tools. But even after all that, the picture isn't finished. There are still questions hanging in the dark like distant stars. Did advanced cultures rise and fall along coasts now hidden under hundreds of feet of water? How many stories were swallowed when the ice sheets melted and the sea crept inland, inch by inch, year by year? How much of what we call myth is actually a blurred photograph of real events at the end of the Ice Age? We don't know, not yet. New cores drilled from ancient ice, new ruins revealed by shifting sands, new maps of the seafloor, they're all still adding pieces to the puzzle, and somewhere deep beneath the waves or buried under layers of silt and time more answers are waiting. For now, you're here, at this tiny moment on the timeline, listening in the dark, your heartbeat, your breath, your thoughts. All of them made possible because generations of survivors refused to give up when the world was colder, harsher, and stranger than anything we can imagine. Thank you for drifting through deep time with me tonight. If you'd like to keep exploring these hidden chapters of our past, you can gently tap like, subscribe for more sleep stories like this, and leave a comment telling me where in the world you're listening from. A city, a village, a tiny room under a vast ancient sky. As you slip towards sleep, remember, you are part of a story that began long before the last ice age ended and will continue long after tonight. The glaciers come and go, the seas rise and fall, species appear and vanish. And for this brief, quiet moment, you're here to witness it. Let the deep time behind you stretch out like a calm, dark ocean. And now you can